Class, I want to cover 4.2, the mean value theorem. So what the mean value theorem says is let f be a function that satisfies the following hypothesis. One, that f is continuous on the closed interval from a to b, and two, that f is differentiable on the open interval from a to b. Then there's a number c in a to b such that f prime c equals f of b minus f of a divided by b minus a. So, f prime c is the instantaneous rate of change. And you'll notice that f of b minus f of a divided by b minus a is the formula for the average rate of change. So what the mean value theorem is saying is that somewhere in the closed interval, if the function's continuous on the closed interval and differentiable on the open interval, that the instantaneous rate of change is equal to the average rate of change. You can also write it this way if you want. So also remember that the instantaneous rate of change is the same thing as the slope of the tangent line. And the average rate of change is the same thing as the slope of the secant line. So you can also think of the mean value theorem as saying that somewhere in the interval, the slope of the tangent line will be equal to the slope of the secant line, which means the same thing as instantaneous rate of change will be equal to average rate of change. And this is just a little picture explaining, say this is the curve in red, and this is from A to B, and the curve is continuous on A to B, and it's differentiable on A to B. And this is the tangent line, and this is the secant line between points A and B. Somewhere, say C, on the interval from A to B, there is an x value for which the slope of the tangent line is equal to the slope of the secant line. So you see these two lines are parallel, so that means they have the same slope. So here's an example. Let's say that f of x is x cubed minus 3x plus 5, and the closed interval is from -1 to 1. So first of all, before using the mean value theorem, you have to ask, does it apply? So you have to make sure that the function is continuous on this closed interval and differentiable on the open interval. This is a polynomial, so it's continuous and differentiable everywhere. So we take the derivative, that'll be 3x squared minus 3, and we substitute in a c, and we set it equal to, and we use the formula, f of b minus f of a over b minus a. So I go f of 1 minus f of minus 1 over 1 minus a minus 1. And so I need to find out what this value is. So I calculate f of 1 and I calculate f of minus 1. I get a 3 here and a 7 here. And in the bottom, of course, I'm going to get 1 minus a minus 1 is a 2. So I have 3 minus 7 over 2, which is minus 4 over 2, which is minus 2. Now I'm going to set f prime. So this is the average rate of change. Now I'm going to set the instantaneous rate of change, or f prime c, equal to minus 2. So this is what we had for f prime c. I set it equal to minus 2, and then I solve the equation. So I add 3 to both sides, so I have 3c squared equal 1, or c squared equal 1/3. Then I use the square root property, c equals plus or minus the square root of 1/3. Both of these values are on the interval from -1 to 1. So there are two values of c where f prime c equals f of b minus f of a over b minus a. That is all there is in this section. The next section is 4.3. And I recorded the second part of 4.3. That was the first lecture I recorded when the pandemic first started here in the United States and when the school was closed and we went online. So there may be things that I say to my students about the pandemic that don't apply now. So, because they had been in a face-to-face class and then suddenly were in an online class. Also, the reason that the whole video isn't there is because I had covered the first part of the lecture in class. And then the second part, we had moved to the online. So anyways, the content should make sense though, but some of my comments may not. All right, so that is it for this section, and I will see you guys later.